this video, I'd like to walk you through some examples of finding derivatives using the chain rule. It's going to be important as we use the chain rule that you are familiar with each of the other derivative formulas. I've copied here in the top right, I've copied the product and quotient rule, and you'll also need the other derivative rules. Let's start with number 1. And remember, for the chain rule, here's the big idea. We're going to take the derivative of the outside function. So in the example number 1, the outside is this thing to the 7th. And then we're going to multiply that times the derivative of this thing on the inside, which is the 3x minus pi. And we multiply those together. So again, we start from the outside and then do the inside. Now the derivative of something to the 7th is going to be 7 times that something to the 1 less than 7. And let's go ahead and fill in that something, the something that was raised to the power, is the 2x minus pi. And we're going to multiply this derivative, the derivative of the outside, times the derivative of the inside. The derivative of 3x is 3, and the derivative of pi is 0, so it's really just 3, right? We could now simplify this by multiplying the 3 and the 7 to get 21. So we'd have 21 times the quantity of 3x minus pi to the 6th power. And let's see if we can find that. And sure enough, it's right here as one of the answers. Let's look at number 2. In number 2, if I rewrite this radical as something to the 1/2, that's one way to do this. Or I could use this fact that the derivative of a square root is 1/2 times the square root. Either one of those out. I would recommend, although you don't have to have this one memorized, I would recommend that you memorize that one just because we use it so often. Like in this case, we're going to be using that. And the radicand is this 2x to the 5th plus 8x cubed minus 2x plus 957. Oh, sorry, that came out a little messy. And then I'm going to multiply the derivative of the outside, so the derivative of a square root, times the derivative of this radicand, this thing that's on the inside. That's the 2x to the 5th. I'll write it more neatly this time. Plus 8x cubed minus 2x plus 957. And when we do the derivative using the power rule or use the formula, we end up with 1/2 times this square root. You know, I'm going to just put the black blob here because we know it's times that 2x to the 5th plus 8x cubed, so on, right? I'm going to multiply this times the derivative of this green thing, the radicand, the piece that's inside. And to do that, I'll just go each term at a time. 2x to the 5th, 2 times 5 is 10. X to the 1 less than 5 is 4. 8 times 3 is 24. Times x to the 1 less than 3 is 2. Derivative of a coefficient times x is just a coefficient. And we could write that the derivative of 957 is 0 because the derivative of a constant is 0. But you don't have to write that, right? We could just leave that 0 off. If I were to rewrite this, putting this green up on top, do you see that we could factor a 2 out? 10 divided by 2 is 5, so we have 10x to the 4th divided by 2 is 5x to the 4th. 24 divided by 2 is 12, so 12x squared. 2 divided by 2 is 1. Why did I do that? Because I noticed that I've got this factor of 2 in the denominator. So in the denominator, I've got this 2 and then the square root of, maybe since this is the final answer, instead of a squiggly, let me go ahead and write that in. We've got 2x to the 5th plus 8x cubed minus 2x plus 9, 57. 2 over 2 is 1. And when I look over here at the possible answers, I can see right here we've got our answer. Number 3. I'm going to copy this and I'm going to make a new page of this. Okay, now that we have room for number 3, I can see that the outside function is the sine. So I'm going to do the derivative of the sine of whatever. In this case, the whatever is the 3x to the 8th plus 2x. And according to the chain rule, what I do is I'm going to multiply that times the derivative of the inside function. And the inside function is the 3x to the 8th plus 2x. Derivative of sine is cosine. So we're going to have the cosine of this whatever. The whatever is the 3x to the 8 plus 2x. And I'm going to multiply that times the derivative of 3x to the 8th plus 2x. 3 times 8 is 24. X to the 7 plus 2. Do you see the important symbols I've left off? Because this isn't quite right. Because I want to ensure that I'm multiplying that cosine times this whole thing. Now, just to be really clear, also, I could take this 24x to the 7th plus 2x and put that as a numerator, or maybe I could factor out a 2. There's a number of ways I could write this. So as I look at the different possible answers, it looks like the answer did just get left here. And, let me get the right pen. Looks like it just got left here. But make sure you're clear that it's the cosine of the 3x to the 8th plus 2x, and that cosine is being multiplied by the 24x to the 7 plus 2. That's number 3. Let's look at number 4. Very similar. Number 4, we're going to recognize that the outside function is the tangent, and the inside function is the 4x cubed plus 7x minus 999 and 3/17. The derivative of tangent. Oh, how do I remember that? You know what? I'm going to think secant, tangent. Now you actually write that down. And if I write it backwards, I get tangent, secant. The derivative of tangent is secant squared. So we're going to have secant squared of this 4x cubed plus 7x minus 999. And then I'm going to multiply that times the derivative of 4x cubed, 12x squared, plus 7. This big frightening thing is just going to be a 0, right? Because the derivative of any constant is 0. And it looks like that's it. So we have the secant squared of 4x cubed plus 7x minus that mixed number times the 12x squared plus 7, the derivative of the inside. That's number 4. Let's move on to number 5. Number 5, this is an important one. This is going to come up often. It'd be helpful to recognize that this is equivalent in the way that we're noting this. It's the same as saying we've got the cosine of x to the 7th power. When I write cosine to the 7th x, it's the cosine of x to the 7th power. So when I do the derivative of this, The outside is the something to the 7th. And then the inside will be the cosine. The derivative of something to the 7th, we use the power rule, so 7 times the cosine of x to the 1 minus 7. And then I'm going to multiply that by the derivative of cosine. The derivative of cosine is sine, and the derivative of any is the opposite, so we get the opposite of sine x. So what is this going to look like? I'm going to pull this negative out in front. So we'd have negative 7. And I'm going to write this cosine to the 6 in this better format. Times the sine of x. And we can find that here in the middle. The opposite is 7. Oh, I'm sorry, that's not quite it, is it? Let's keep going. Where do we find that? Here we go. The opposite of 7 times sine x times cosine to the 6th x. Number 6, do you see how different this number 6 is from number 5? In number 6, we've got the cosine of x to the 7th. So the outside is the cosine. The outside is the cosine. And we're going to multiply the derivative of the cosine times the derivative of the inside. And the inside, in this case, is the x to the 7th. The derivative of cosine is going to be the opposite of sine, because the derivative of any is negative. And what was that the cosine of? It was the cosine of x to the 7th, right? And then we multiply that times the derivative of 7x, or x to the 7th, which is going to be 7x to the 1 less than 7. I could rewrite this as the opposite of 7 x to the 6th times the sine of x to the 7th. And that one is right here on the answer box. One more, number 7. This one's a little bit more tricky. And so you know what I'm going to actually do is I'm going to move to a clean page. When we look at this number 7, we want to recognize that the outside is going to be the something cubed. This cubed is on the outside, right? So we're going to do the derivative of the something cubed. And the inside is going to be the x plus 2 over x plus 3. So we're going to multiply by the derivative of that inside function, the x plus 2 over x plus 3. Off to the side, let's talk about the derivative of this quotient. To do the derivative of a quotient, I'm going to note that the f function, the numerator, is x plus 2. Derivative of x plus 2 is 1. The g function, the denominator, is x plus 3, and the derivative of x plus 3 is 1. And I'm going to write this formula out each time. I know it's right here in front of me, but it's really beneficial to me, I find, to write that each time, because then it's almost like a foolproof method. I can't go wrong, or at least it's pretty challenging to make a mistake at this point. But I'm going to look at each piece. So this g is the x plus 3. F prime is 1, so x plus 3 times 1, minus f, which is x plus 2, times g prime, which is 1. When I multiply x plus 2 times 1, I just get x plus 2, all over g squared. So all over x plus 3 times x plus 3. When I simplify this, I'm going to be really mindful that the subtraction is going to distribute, right? So it's the minus x plus 2, minus the quantity of x plus 2 is the same as adding the opposite of x to the opposite of 2. So I've got x minus x, x minus x, those cancel each other out. And then I have 3 minus 2 is 1 in the numerator. And that's all over x plus 3 quantity squared. That's just a quick review of the quotient rule. So back to our problem number 7. What we were going to do is the derivative of the outside. So the derivative of something cubed is 3 times that something squared, right? So 3 times this quotient, x plus 2 over x plus 3. But now it's 1 less than 3, which is 2. And I'm going to multiply that times the derivative of the quotient, which I got over here off to the side, right? That was 1 over x plus 3 squared. When you look through the answer key over here, we don't see anything exactly like this, but watch what I can do here. I'm going to recognize that that is like a fraction. I've got a 3 times a fraction times a fraction. And the 3 is like a 3 over 1, so it's going to be in the numerator. And then I've got an x plus 2 squared in the numerator. And I've got an x plus 3 squared in the denominator. And then I have this green x plus 3 squared in the denominator. So all together, I've got this 3 x plus 2 squared. Nothing's going to divide out, but it does simplify. That's over x plus 3 to the 2 plus 2 squared, and then times another square, so to the 4th. And sure enough, when I look over here at the different possible answers, it's right here in the top right corner. Well, that wraps up the first column. If you want to continue to the second column, you're welcome to continue watching the next video.